aircraft testing, E3. What makes being an E3 engineer difficult?
I think what makes being an E3 engineer hard is the breadth that is required to actually perform that work. Unlike a lot of the domains that you work in, so structures or fuels, you don't really get the opportunity to specialize when it's E3 because it touches so many different parts of the aircraft. You have to understand structures and the impacts of coatings and how fasteners are installed, and really the effects of those don't become apparent until you put it all together. So we're very commonly put in high leverage situations at key parts of the program, and if we get something right or we get something wrong, it has material impacts on the program. So we're always kind of under fire when we're doing that stuff. Aircraft testing is kind of the final straw in a lot of the programs. Frankly, I wish we did it a lot earlier in programs, but you need to build it to be able to test it. That's really where you characterize how the external environment gets inside. So you have external RF environments from transmitters, high power transmitters and so forth. Lightning and other electromagnetic effects can cause all sorts of damage and equipment upsets. And by the time you run these tests, if you haven't done simulation, you're at a point where it's really hard to fix it. And at EMA, we try to combine simulation. We try to simulate what you can and test what you have to is kind of the moniker that we use, just to try to avoid those. E3 is a gap. They don't make E3 engineers in college. You require so many different skill sets to do it, and frankly, a lot of the E3 engineers we work with are at a huge disadvantage. We at EMA work on hundreds of programs every year, and we're kind of the culmination of all the experience we get from all the lessons learned from those. And unfortunately, a lot of the customers we work with have awesome E3 engineers that have only worked a few programs, and so we're able to come in and bring all of that expertise and the experience that we have working on these programs with us to help you make better design decisions so that you don't have to wait until the end of your program to figure out what works, what doesn't work, and have to start over. A lot of my experience on both military and commercial programs means that you have human beings that are having to review and accept data. Did you or did you not show compliance? And as a DER, I can sign off and I have full authority, so I can state that I approve this data there. But for new and novel designs, there's a lot more oversight, and that's really evident in the eVTOL industry right now. We're learning how to certify those airplanes. And if you just show a whole bunch of data to an administrator, to your FAA, to the Air Force, or any one of the military consultant programs there, it's really tough for them to understand that you showed a green light and that means you pass. How did you get there? Did you follow good processes there? And I think the storytelling is something that we bring that's really unique because we understand how it needs to be communicated because we've done it so many times. And that storytelling shows rigor, it shows that you know what you're doing, it shows that you didn't cut corners, and that goes a long way with earning trust with the people that matter. We've embarked on probably the largest effort of training and staff growth, I think, as a company in our almost 50 plus years of existence that we've been on there, knowing that at EMA, we have to train the next set of experts in the industry. We're not going to find them in many places. We certainly try to find them as much as we can, but in reality, that comes from development. We certainly are working our hardest to do that. So somebody that gets into E3, I think it's really difficult to find what part of E3 you're going to get into because there's forms of test, there's simulation, there's everything from board level analyses all the way up to big giant physics problems like complex modeling. And we have specialized groups within EMA that are really good at all of those. And I think we do a really good job of giving people an opportunity to try a whole bunch of things and feel really what their skill set will adapt to. But there's a lot of really baseline traits that make you adaptable with it, a lot of scripting and data processing. And we spend a lot of time mentoring people on how to take kind of amorphous problems. I need to pass HERF on this airplane. And a lot of what we have to do from a mentoring standpoint is explain, what does HERF mean? Let's build out your understanding of what the RF environment is, what it does. Here are the ways, here's the standards that talk to you about how you can show compliance to that. And then build up example workflows that we use internally here to work through problems that mimic the types of things we see on a day-to-day basis. We have a lot of interest in adding PCI or pulse current injection EMP capabilities in the coming years to better support our military programs that we work on. At the aircraft level, we're continuing to mature our HERF and Lightning aircraft test capabilities. That's going to allow us to take more measurements in parallel and expedite our test campaigns, which obviously will save customers money and schedule time, which is really important to us.